Just a quick note for all animation videos that you're going to be watching is that the software that captures the video actually captures at a frame rate of 10 frames per second. So it's going to look choppy no matter what in these videos, but once you actually run it in your program, you're going to find that things move a lot smoother and cleaner. Thanks for listening. So now it's time to get into some of the really interesting stuff. Animation. And what you need to realize to do animation in your video games is that animation in our Java game engine works the same way classical animation does. Classical animation basically shows an image and then shows a slightly different image and then a slightly different image from that one, then a slightly different image from that one. And basically you get a sequence of slight changes that when displayed in really quick succession, it simulates motion. Basically what you get is something like this. This is what's called a sprite sheet. It's a single image that's made up of a whole bunch of slightly different images from the one previous. So they're numbered from the very beginning, this one being frame 0, the one right next to it, frame 1, frame 2, frame 3, frame 4, frame 5. And then it goes back to the left again, 6, 7, 8, 9, 10, 11, and it keeps going, and this one has 5 rows, 1, 2, 3, 4, 5, and 6 columns. 1, 2, 3, 4, 5, 6. But they're numbered from, it doesn't really matter how they're numbered, but they're numbered from 0 just like everything else is. So in total we have 6 times 5 individual frames, which means there's 30 total frames in this animation. So if our program runs at 60 frames per second, and there's 30 frames in this animation, that means it'll take exactly 1/2 of a second to display the entire animation. So you got to keep that in mind when you're doing your programs, how long it takes for certain things to happen. So what we want to do, and the way animation is going to work for us, is we can't just draw this whole image at one time. That would be ridiculous. You wouldn't actually see any animation. You would just see one big image of a whole bunch of still pictures. That's not very useful. So for example, let's quickly throw that in our program so we can see what that looks like. So we're gonna load that image, which is called walker.png. So we're gonna load it the same way that we load any sprite sheet. So I'm gonna say sprite sheet walker img. We're gonna load the content down here. Walker img is equal to a new sprite sheet. And then we're just going to follow the same path as before. Load image dot from file, and then we have to specify exactly where that is, which is in your images folder. Oops, forgot my slash. Images / sprites / walker.png. Great. And now if we go to draw that, oh sorry, I guess we need a destination rectangle. We could say walker image.dest.rec is equal to a new rectangle. Let's just throw it over, let's say 50, 250. And now for its width and height, we can still do the same thing we always did. Walker image.get frame width and walker image.get frame height. And that will still give us a proper frame width and height. And then all we have to do is draw it. So down in our draw code, way down here, we're going to draw it after our mushroom but before our hello world. Draw.sprite, gfx, and then walker image. So if we were to draw this, we actually get the whole image, but it's huge. So we're actually seeing, you can see a whole bunch of different frames in here, but the picture itself is gigantic. So it's too big for us, in fact. But we don't want the whole image. We only want one piece of the image. Again, looking at this chart, what we have to realize is that we're only going to draw one of these frames at any given time. Now the Java game engine is actually built to handle this for you. All you have to do is specify certain information about your sprite sheet, and it will set everything up for you. All you have to do is say start animating. So basically what it's going to do is it's going to use like a cookie cutter, and based on what sequence number it's currently on, what frame number it's currently on, it's going to grab the proper frame. Now there's a couple things you need to realize about any sprite sheet. First and foremost, a good sprite sheet is either in a single row or it's in a grid formation like we see like this. Secondly, every single frame in the sprite sheet needs to have the exact same size, so the same width and the same height as all the other frames. If it doesn't, what's going to happen is you're going to see that things are going to they're going to look jittery, or it's going to give you a piece of something else, and it's not going to look very well. So you need to make sure that your sprite sheet has, each frame has the exact same width and height, the exact same dimensions. Sorry about that. So in terms of code, you set it up just like you would load any other image, except we have to give it some extra data. So let's go over and check that out. Inside of our code, where we load our image, right here on the load image.from file, we need to specify 5 more pieces of information. Is it 5? 1, 2, 3, 4, 5. Yeah, I believe so. So first of all, we got to look at our sprite sheet and say, how many rows are there? So looking at this, there are 1, 2, 3, 4, 5 rows. So there's 5 rows. Good. And it needs to know how many columns there are. 1, 2, 3, 4, 5, 6. So there's 6 columns. Next thing it wants to know is which frame number should it start on. Now remember, they're numbered from 0 to the end. So if the top left one is going to be 0, if that's where I want to start, then I'm going to specify as 0 here. And the next thing it wants to know is how many total frames are in the animation itself. Now it doesn't figure that out by saying just 5 times 6 is equal to 30. Duh, of course that's what it is. Because maybe your animation doesn't actually fill up the grid entirely. Maybe the last 3 of these frames are not actually full, and it only goes up to here. That's very possible. So by specifying the number of frames, the program knows not to go past the end of that and show some blank frames. So we need to just specify. In this case, we actually do have 5 times 6, which is 30, but that is just a coincidence. Now the next piece of information, let's just put it at 1 for now, and I'll go over in detail what it means in a minute. But for now, we're just going to leave it at 1. So using this information, we have now set up our sprite sheet. The only thing we have to do now is tell it to start animating. Now in our programs, we may say, you know what, start animating whenever I hit the walk button. Or we may say start animating after a certain amount of time. That's up to us. But for my demonstration purposes right now, I just want it to start animating immediately. So I'm going to put this in my load content. Normally you would trigger an animation inside of update based on some type of key input by the user. But for now, we're just going to force it right now. So all we have to do is say walker image dot start animation. That's it. And now it's done, and it'll work. And there we go. We have a fully animated image. There's no extra details you see on the screen. We can see that the mushroom's actually drawn behind it because it was drawn first. And it looks very smooth. It looks very clean. No problem there at all. Now what I want to show you is actually one of the extra abilities of start animation is you can actually specify a number. And that number will specify how many full cycles of the animation you want it to run. You may not want every animation to run forever. Campfire, sure. But if you're making a fighting game and the character punches, you don't want him just picture a guy just continually punching when you ever hit your punch key and he just goes forever and ever and ever and ever again. It wouldn't be very helpful. So what we want to do is, or what we can do is we can specify a specific number of times to cycle. So if I just do it once and run the program, oops, why do I have a bug? Because I'm missing my semicolon. We run our program, he does it once and stops. That was one full animation, took a half a second. Maybe I want it to run 3 times. Run it. 1, 2, 3, and stop. Good. And it ends on the last frame possible. It's still drawing, that's fine, but it's not currently animating at this point. So we can say start animation, that will animate forever. You could also, there is other functionality as well. which we'll get into in a second. But basically, start animation is the big one that you're going to be using, and that allows you to display it. Now don't forget, this is still an image, so you can do things like play with like its transparency and all that other kind of stuff. When you draw it, you can rotate it, you can flip it, all that kind of stuff is possible. If I want them to run the opposite way, then I just say Walker image dot flip horizontally, and now if I run it, he's not running the other way. Simple as that. So it's very simple to control these images. In the next video, I'm going to show you how to do a few more options and play with it a little bit more. And that's it.